Hello everyone, and thanks for being here with us today. In this video, we will discuss the performance overhead that can result from collecting too much observable data and how it can be minimized. So let's dive into what this challenge means and how to overcome it. While continuously assessing the quality of a web application at runtime relies on instrumenting it with a data collection agent, as we can see over here. This agent will export the observable data to the data collector using a data exporter. Then the collector will finally flush the data to the data storage. Now, what we're mostly concerned about in this workflow is the impact of the agent's data collection strategy on the performance of the instrumented application and how to minimize it as much as possible. Now, if the agent collects data indiscriminately and exports it too frequently to the collector, then the incurred performance overhead would be too considerable on the application. Now, this usually causes increased CPU usage, higher memory consumption, and excessive network traffic, all of which can slow down the application, make it lag, and eventually, if not managed properly, the data collection intended to improve quality can ironically degrade user experience. Now, unfortunately, this is usually the case with existing general purpose observability tools like OpenTelemetry and others. By default, these tools collect general purpose data about an application to have a holistic understanding about its state and behavior. And despite providing the necessary APIs to balance between the collected data and the incurred performance overhead, the data collection strategies of these tools don't account for quality concerns explicitly when collecting the data. And they also leave the exportation policy and configurations to be set explicitly by the users. So, as such, if users want to properly learn about and customize these tools to fit their quality interests, they must acquire technical expertise through a steep learning curve, which isn't accessible to all of our stakeholders having different roles and levels of expertise. For all of these reasons, minimizing the performance overhead of data collection for the continuous quality assessment of quality applications proves to be quite challenging. So to address this challenge, SoftScanner adopts a targeted instrumented strategy. Instead of collecting general purpose data indiscriminately like existing observability tools by default, the generated agent will only focus on the required data, which would be identified by the SoftScanner quality mapping model for the instrumented application and the selected goals. And to avoid continuously overloading the network by frequently exporting the collected data, the generated agent will implicitly aggregate the observable data into batches that will be exported periodically to the telemetry collector in order basically to minimize the performance overhead on the application. And this will in turn ensure the responsiveness and normal behavior of this application without degrading user experience. So now let's check the SoftScanner platform to see how this is done in practice. So in this scenario, we assume our stakeholder is interested in assessing their application, specifically to see its user engagement. And as you can see, we've already provided the necessary metadata for the application and we've set it accordingly. Now, let's select our user engagement goal, which is a sub-goal of interaction capability. And we'll select it along with all of its goals. And let's simply launch the quality assessment process and wait for the instrumentation to complete. Now that the instrumentation is complete, let's create some user interaction sessions to see which metrics are being computed and what data is being collected. So let's start with a very basic session for this context. Here's a new post, whatever, and let's simply like the post. And if we go over here, we can see that we already have our goals. Let's take a look at, for instance, the metrics for popularity. Now you can see we have, for instance, over here, NOU, NOV, NOS. Each of these metrics can be consulted for more details, as we've seen in the previous demo about the usage of SoftScanner. Now, all of these different metrics will require different kinds of observable data in order to be computed. So for the number of users, for instance, we would require information about the user, such as the user visit and session IDs. Whereas for metrics such as, let's say, UIFU, which is user interaction frequency per user, we would actually need information about all the different interactions and different sessions in order to compute it. So all of this information is crucial for the computation of these metrics. And in order to see what kind of data is required, let's take a look at the actual telemetry data or observable data that has been collected. And as you can see, let's refresh our collection. Now we have one document. Let's consult this document. So in this document, we can see, first of all, the name of our application, and we can see that it has one bundle. Inside this bundle, we can see the name of the bundle that has been used, so the name of our actual agent, and we can see the collected telemetry data in here and the actual assessment. So let's examine these traces. Since we collected the user interaction traces over here, you can see, for instance, that we have a navigation trace, and for each trace, we can actually see different information about the event, including the information about the user, the session ID, the visit ID, all of which are crucial in order to compute all of these metrics that we saw earlier. If we take a look at another trace, let's see this one. This is a simple click. This one is another navigation. This one is another click. And you can keep going on, and you can just see the attributes as well over here in order to see these different values. We can also see duration and end time, which could also be used eventually in other contexts. So let's see another scenario now with another quality goal to see which metrics would be computed and what data would be collected accordingly. So in this scenario, we assume our stakeholder is interested in assessing the performance efficiency, specifically the time behavior of their back-end Node.js application, for which I already provided the metadata, as you can see over here. Now, let's basically select performance efficiency and specifically time behavior. And let's launch the quality assessment process and wait for the instrumentation to complete. So now that the instrumentation is complete, let's create some user interaction sessions to see which metrics are being computed and what data is being collected. So you can see that the back end is currently running. We're going to actually open the front end. So in this session, we're going to add a new user. Okay, let's provide the email, whatever over here as well. Let's provide this number, select a country, favorite number, color, and here's our new user. Now let's get back to SoftScanner and let's actually examine our time behavior goal and see its metrics. Now, as you can see, we have all the necessary metrics in order to evaluate time behavior. And again, time behavior is the response and processing times and throughput rates of the software under stated conditions. And it's a sub-goal of performance efficiency. And you can see over here, for instance, we have NHR, which is the number of HTTP requests, for instance, observed at the telemetry data. Over here, we have a single request. ART, which is the average response time. Let's say P95, which is the 95th percentile response time, and so on. And as you can see, all of these data require, all of these metrics require data about the actual HTTP requests that have been sent to the backend in order to be computed accordingly. If we do open another session, you can also, let's say, add another post over here. There's another post just to increase the number of HTTP requests. So here's another post. Okay, we're gonna like it. We're gonna go see the users, see the user's profile. Let's search for the user over here. Okay, now let's take a look at these metrics again. You can see that the values have changed over time. As we can see, we have new values now for in HR, ART. And what we need to do in order to see how these metrics have been computed, let's just examine the actual telemetry that has been collected. So let's go back over here. Let's refresh. And as you can see right now, we have two different documents for our applications over here. We have one for the front end, with which we tested with user engagement with its own bundles. And now we have one for the back end with its own bundles as well. Let's take a look at the bundle. We can see its name. We can see the telemetry data and assessments. Now, if we examine these different objects and telemetry data, we can see, for instance, that we have a middleware over here to trace the middleware that occurred. We can have another middleware as well. We can have the actual router over here, and we can see that it's actually an HTTP route over here, so it corresponds to a trace a trace of an HTTP request. And here's another HTTP request as well with its own information. So as you can see, to summarize, by focusing solely on collecting the necessary data for the selected quality goals and implicitly set the exploitation policy without user intervention, SoftScanner's targeted instrumentation strategy minimizes the performance overhead typically seen with general purpose observability tools like OpenTelemetry by default. So this ensures that web applications remain responsive while quality assessments are carried out efficiently without burdening system resources. In our next video, we'll explore how SoftScanner minimizes code-based modifications for this instrumentation. Thank you for watching and see you in the next video.